Hi, welcome to MSK Life Science Simplified. I am Salis Idris. In this video, we are going to talk about COVID-19. That is the novel coronavirus discovered in 2019. What you guys have to know is that this video is for education and information purpose only. All the information in this video are up to date as of today, April 22, 2020. So we'll start with a historic overview and some epidemiological factors of the virus. So let's get started. So coronavirus was discovered in 1965 by Tyrrell and his associates. And say that the virus was discovered by Tyrrell and his associates in 1965. So Tyrrell discovered this virus while working with a group of virologists on a number of animal viruses. He discovered this new virus and gave it the name corona because of its crown-like appearance. So you can say that the name corona means crown-like appearance. The name corona means crown-like appearance. But the structure of the virus was elucidated in 1980. After an international meeting was held at the Institute of Virology and Immunobiology of the University of Wolfsburg in Germany. They described that the virus has a quite simple structure, which comprises of 3 major structural proteins and a positive sense single-stranded RNA molecule. So let's take a look at the structure of the virus. So now, these are the peripheral proteins. I colored them red. So these peripheral proteins are called spike proteins, and they are the proteins that the virus uses and binds to its host cell. So specifically, the type of the peripheral protein that COVID-19 virus uses is called S-spike. So the type of spike protein that COVID-19 virus uses and binds to its host cell is S-spike. So this S-spike have 2 domains, S1 and S2 domain. So let's see. 2 domains, S1, and what does S1 do? S1 is used by the virus to bind the host cell receptor. So you can say that S1 binding host cell receptor. That's the function of S1. So for the S2, what does S1 do? S1 helps the virus for entry into the host cell. So you can say that S2 entry into host cell. That's for S2. So that is the first protein. So the second protein is HE protein, which are called hemagglutinin esterase glycoproteins. The function of this protein to this virus is that they remove sialic acid that might be found on the surface of the host cell receptor. So, on the surface of the host cell. So, in the surface of when they remove sialic acid, this will help in proper binding of the S-spike protein to the receptor. So, we can say that HE protein removes sialic acid. The sialic acid. So this is function of the HE protein. So the third protein is the nucleocapsid. I colored it in blue. This is the third protein. Nucleocapsid. And this is a protein that is found in complex with the viral RNA genome. The function of this protein is that it helps the virus in packaging the viral RNA. So we can say that it helps in packaging viral RNA molecule, which is very necessary for self-assembly of the virus and also proper replication of the viral RNA molecule. So we can say that the nucleocapsid function is packaging of viral RNA. And this is very important for self-assembly some assembly of the virus, and ultimately replication fidelity. Replication fidelity. So these are the three major proteins that are found in this virus. So the other component of this virus is the viral RNA, which is the genetic material of the virus. So this viral RNA molecule is a positive sense single-stranded RNA molecule. And this positive sense single-stranded RNA molecule is about 27 to 32 kilobase, which is quite very large protein. It is considered as the second largest of all RNA genomes. So the molecular weight of this protein is about 27 to 32 kilobase, and it is considered as the second largest of all RNA genome. So that is for the structure of the virus. So this virus is completely found in bat. So you can see it. Here is my virus. So this is found in bat, and as a result, it is called bat coronaviruses. And the bat is considered as the animal reservoir of this virus. You can see that. We can call it bat coronavirus. And the bat is the host reservoir of the virus. So next thing is that this virus is only pathogenic to the respiratory system. Either it form an infection in humans or in animals. It only affects the respiratory system. So that is what we know about the virus. So another important thing that I want to explain here is that this virus has caused about 4 virus outbreaks from 2002 to 2019, including COVID-19. So 3 of these 4 virus outbreaks were found in humans. Let's see them. So you see them, 1, 2, 3. The first of this coronavirus outbreak was SARS, and then the second, MERS, and then the third, COVID-19. These are the 3 virus outbreaks that were caused by coronavirus. So let's see a little about the history. Let's see a little about how those outbreaks come. So, as I tell you, the first coronavirus outbreak was SARS. SARS means severe acute respiratory syndrome. So this outbreak occurs in 2002. So let's see how it gets started. So as I tell you, bat is the animal reservoir. So in bat, the virus mutated. Bat already have the virus. You know that. So from bat, the virus mutated. It mutated in such a way that it can it can cause infection in another animal. So the animal infect is believed to be a civet. So within civet, this virus mutated again. It mutated and caused the SARS outbreak in humans in 2002. The first case of this outbreak occurs in Guangdong in China. First case in Guangdong in China. And it resulted in about 8,000 total cases and about 800 total deaths. So let's write this down. Total cases, I will use TC for total cases. So total cases is equal to 8,000 total case of SARS. And I use TD for total death. So this SARS outbreak resulted in about 800 total death. So that is for the SARS outbreak of 2002. So a couple of years later, we witnessed another second coronavirus outbreak called MERS. So this MERS outbreak occurs in 2012. And look at how it gets started. As you all know, bat have the virus. So from bat, this is my bat. So from bat, the virus mutated. It mutated and infected another animal. So the animal infected here is a camel. So within camel, the virus mutated again. It mutated and caused the MERS outbreak of 2012. The first case of this outbreak occurs in Middle East. Middle East, and therefore the name Middle East Respiratory Syndrome. So this is the second human coronavirus outbreak. This coronavirus outbreak resulted in about 2,500 total cases and about 850 total deaths. Let's write this down. So total case 2,500 total cases, and that is worldwide. Total death is 850 total death. That is for the mass outbreak of 2012. So a couple of years later, we can say 7 years from 2012 to 2019, we witnessed the COVID-19, which started in December 2019. So this is the third outbreak, human outbreak of coronavirus. Look at how it gets started too. From birth, as we know, birth is the animal example. Get the virus. So in the birth, the virus mutated. It mutated and infected another animal. The animal infect here is still not matured, but it is somehow to be believed to be a pangolin. This is pangolin. Although it is not still matured, so within pangolin, the virus mutated again. It mutated and infected humans, and therefore caused the COVID-19 pandemic. The first case of this COVID-19 was reported in Wuhan, and as of today, 22nd April 2020, we have 2,565,059 total cases and about 177,496 total deaths. That is one one. Write down this number. So this number of total cases we have for COVID-19. That is total case 2,565,959 total cases. And for the total death, we have 177,496 total deaths, and that is worldwide. So that is what we know about the outbreaks of coronavirus. But another important thing that I want to highlight is not just the zoonotic effect, how the virus comes to be, how it causes those infections. Because everyone is scared about the virus, and we don't have to overreact the virus or underreact the virus. So another important thing I want to explain is the case fatality rate. So the case fatality rate is a term that is used to describe the rate of severity, the dangerousness of the disease, or to say the mortality of the disease. So a case fatality, we have a simple formula: case fatality rate equals to total death all over total case times 100. And this will give you the mortality of the disease. So let's say the mortality of the 3 coronavirus outbreak. So this is for SARS. SARS, we have total case 8,000, total death 800. We divide this and we multiply by 100. We have a number of around 10%, which is quite decent. So the second coronavirus outbreak, that is MERS. This total case is 2,500. We divide it with the total death 850, and we multiply this by 200. We have a mortality of about 33%, which is quite very serious. So let's see for COVID-19. So for COVID-19, we divide our total death 177,496 total death, with total cases, which is 2,565,059 total cases, and we multiply by 100, we get a factor of around 7%. So that is for COVID-19. And the mortality rate for COVID-19 can even be lower. You ask me how? Because this number of total cases does not reflect all the people that are infected with the virus. Because some people might have the virus, but they are not showing the symptoms. We couldn't count them among the infected people. They are not coughing, they are not sneezing, no difficulty in breathing. So technically, when we add this number will increase, and that will decrease our mortality rate. But in any case, Among all the 3 human coronavirus outbreaks, the COVID-19 appears to get the least of mortality, but it gets a lot of the concern. We are much more scared of it. Why? It's because of the large number of total cases and also the large number of the total deaths. And what is done in this large number? The R0. That is the basic reproductive ratio, or to say the basic reproductive factor. And this R0 is just a term that's used to describe the rate of spreadability. How many persons can each infected person infect? So the R0 for COVID-19 is somehow from 2 to 3. That means each infected person can infect 2 or 3 more people. So let's take 3 as for the worst of the case. It can be even be high. So one person infect 3, and this 3 will infect 3 more. We have 9 here. Each will infect 3. We have the number of exponentially rising from 1, 3, 9, 27. And that is what accounts for the large number of total cases. So how can we stop this? It's by self-quarantine. We isolate ourselves. We stay at home. If you witness any symptoms of this virus, you are coughing, sneezing, the fever, difficulty in breathing, you stay at home. Monitor the symptoms. Is the symptom getting any worse? If it is, you contact your healthcare provider. You don't have to go out because you might infect other people. The virus doesn't move, but we move it. When we stay moving, the virus stopped. So the best way for us is to stay at home. Stay safe at home. Quarantine ourselves. So that is what we know about this virus. I hope this video makes sense, and if it really does, give us a like and don't forget to subscribe as we will keep you up to date on this virus. I'm Salis Idris. Love you all. Stay safe.